Thank you everyone for showing up to my lightning talk. As mentioned, I'll be talking about HTML Canvas, how to make your website stand out with modern day web content. I'm Kevin Mongiello, a software engineer and also a Canvas enthusiast. So let's get started. Oops. All right. So I'll start with a question. What is the internet? And you might think of servers, networks, and data, computers, and things like that. But from a user perspective, it kind of looks a lot like text and graphics. So here's another question. What makes one website better than another? And it's a bit subjective. There's really no exact answer. But if I were to give it an answer, I would say I like when they're fast and its speed matches cognitive abilities and physical reflexes. I like when they're dynamic and they change over time depending on how we use it. I like when they're interactive because who doesn't love real-time responses? And I like when they're aesthetically pleasing and they reduce the mental friction and increase enjoyment. So all those things that I just mentioned, Canvas basically provides a way for us to give our users. A Canvas in its simplest form is just a bitmap to draw graphics. And it provides us some low-level JavaScript APIs for really super fast drawing of graphics. And that enables us to create dynamic, interactive, animated, and stunning web content in a way that is just not possible with regular DOM nodes. And to sort of prove my point, let me walk you through a simple demonstration. So here I've put together a little something, and we're going to basically test the performance of animating regular DOM nodes and animating using Canvas. So what's going to happen is every time I click on this big white box, I'm going to generate some objects, and they're going to be painted on the screen and be animated. You'll see at the top of the screen, there's a big blue box that says 60 FPS. That is our monitor for checking how fast our animation is working. We want it as high, we want that number as high as possible and as close to 60 frames per second as possible. And that will guarantee that we have a really smooth animation. You'll also see that every time I'm adding objects, that count number of objects will go up to show us how many objects are being painted on the screen at one time. And just a quick little note that there's going to be a lot of colorful boxes being painted on the screen, so it might be a little bit of like a flashing light effect. So if you have any problem with that or feel uncomfortable, please focus on this gray outline around the box. So let's get started. I'm going to start clicking on the screen and generating boxes. And I'm just going to keep going up to 500. Up, and I can already tell it's starting to get really slow. And if you see that monitor, we're right around 30 frames per second. And you can tell the boxes are kind of slowing down. So I keep adding boxes. That number will keep going down, the frames per second. And it's really starting to get kind of ugly looking. There's really no smooth animations. And we're only at about 1,800 boxes being drawn and animated on the screen. And so this is just a recap. This is using the DOM elements. I'm going to refresh the screen just to pause that. Let's see what we can do with Canvas. So same exact setup. I'm going to click on the screen and start generating boxes with Canvas. Now, instead of generating 50 at a time, every time I click, I'm generating 500. And let's see where it starts to break. So I'm already way past the breaking point of the DOM elements. We're around an order of magnitude higher, still looking smooth. The frames per second, we have a little bit of oscillation, but it's above 30, right around 40. And let's see if I keep adding objects, yeah, we're starting to get, a little slow, down around 20 frames per second. But if you look at the number of objects we're able to paint on screen, it's pretty astounding. We're able to draw, 10 or 20 times more objects and have them animate on screen in a pretty smooth, um, performance. So as you can see, Canvas is just a lot faster, a lot better at drawing graphics on screen. So what really makes Canvas so much more performant? We need to know a little bit about animation. And to really kind of boil it down to its simplest form, a live animation is really composed of 2 or maybe 3 steps. The two main steps is render and paint. And then the third step would be to wait some period of time, delay, before we render and paint again. Canvas is really good at this because it operates in what's called immediate mode. The graphic on the right shows an illustration of what immediate mode looks like. In immediate mode, the code is written imperatively, which means there's no delay between your code and the call to paint. So as soon as the browser runs our code, it immediately paints, which means that our code can be painted immediately, hence the name immediate mode. Now, let's compare that with how traditional DOM elements are painted on the screen. They use what's called retained mode. And on the right, you see a similar illustration, but you notice that in between our code on the left of the illustration and the browser painting on the right, there's that middle step where the browser has some code that's running. Also note that this code is written declaratively, which means that instead of us telling exactly what we want to paint on the screen, we kind of describe it with HTML and CSS. And then the browser in the middle has to parse that and figure out like what that means and do a bunch of extra steps in order to inevitably paint it on the screen. So that results in slowing down the time to paint. And it also uses more memory. And as you can see, these are some of the steps that the browser goes through in between us describing what we want to happen with the code and it actually being painted on the screen. Another thing is that Canvas leverages hardware acceleration. What that means is that it can use the GPU to make things much faster. The CPU can only really do things and perform tasks serially, one at a time, whereas the GPU can handle several tasks in parallel and execute them all simultaneously. And so that really speeds things up. It makes the CPU for much slower drawing and the GPU much faster. So let's see what it means to actually make some code with Canvas and like what that actually looks like. I've got a basic HTML setup right here. And the really most important thing is this, two things, this Canvas element right here and this script. That is all the HTML that I'm going to be really needing for the demo. This Canvas element is what gives us that JavaScript API to work with and the medium on the screen to paint into. And all the magic happens here in this JavaScript. So let's open this JavaScript up. To get started, I'm going to get a reference to the canvas. Then I'm going to tell the canvas that I want its 2D drawing context. It has a few drawing contexts, but we'll just use the 2D right now. I do some, setting the width and the height on it, and I return this drawing context. This drawing context is the thing that I actually use to tell the browser what I want to paint. So here I have a helper function that accepts an object and a context. It tells Canvas, hey, this is the color, this is the fill that I want to use. and it accepts any CSS property for color. Right now I'm using HSL. And then here is how we actually draw, say, like a rectangle. We use context, fill rect. We supply an X coordinate, a Y coordinate, a width, and a height, and that's it. Rather than describing a div node and giving it a style and letting the browser figure out where to put it on the screen, we tell it the exact coordinates, the exact width, and the exact height, and it happens immediately. Scroll down a little bit. Here's more of the setup, the general setup that we sort of went through. I'm generating some objects, and this is the part that is at the core of any interactive animation with Canvas. At the start of every, I'm creating a helper function here, which is going to be the animation call. This is our render function. So at the start of every paint or every animation cycle, this animation function is going to run. First, it's going to clear the canvas. It has to clear that bitmap so that we can have a fresh paint. Then I'm going to iterate through my objects, and I'm going to call this render function, which takes the objects, some parameters, some coefficients, and a mouse position, and then it paints it. You've already seen this paint function, and this render function. It's a little complicated, so we'll leave it as a black box for now. Let's see what happens when we run our code. So I'm accepting a mouse position, and when I hover over this text, voila.
That is awesome.
We get modern day web content. It's interactive, it's interacting to my mouse, it's changing over time, it's dynamic, it's fun to look at, and it's fast. Let me restart that just to pause it. So in review, the benefits of Canvas are that it's a powerful tool to render web content because it's fast, dynamic, interactive, animated, and beautiful. It's minimal. It paints exactly what we want and only what we want immediately to the screen. There's no clunky browser code to run that slows us down. It's lightweight. It uses a lot less memory than HTML objects. And it's fast because it's hardware accelerated. Also in review, some of the implementation details. Animation is essentially just 2 steps, rendering and painting. And to create a unique interactive graphic, we create some objects, update their position and color, paint them inside an animation loop. Further considerations, because it's not all, rainbows and butterflies, there are some downsides to using Canvas. Number one is there's more responsibilities, including optimizing the code. Normally the browser will have a lot of built-in optimizations for you when using HTML, but we're not using any of that. So it's up to us to optimize the code. We have to manage state. So you have to manage the objects, you have to know, what you want to paint on screen and what you don't want to paint on screen. Again, we don't get any of that for free from the browser. We have to manage our own hit detection. So if you wanted to determine whether an object on screen had been clicked, there's no such thing as just assigning a click handler. You actually have to see what exact pixel you're clicking on and then determine if there's an object on screen at that position, and then you'll know whether or not there's a click. So that is all something that you would have to roll out on your own if you wanted to work with Canvas. Some other, so how do we get around that? Because there's a way. There's a lot of great open source third-party libraries that abstract that low-level complexity out. while still providing the functionality and baking in the optimizations for free. And some of the ones that I recommend are Pixie.js for doing really fast 2D rendering, and 3.js if you want to get into 3D rendering, think like virtual reality. There's a lot of really great possibilities if you want to go with that. And so, I want to stress that, Canvas is not just creating, it doesn't just give us the ability to create colorful boxes on screen. There's a ton of really practical use cases that you can develop with Canvas. Some applications are made completely inside of Canvas. If you're familiar with Miro or Figma, open up the dev tools and check it out. They're using Canvas for most of their UI. Games can be developed on Canvas. You can, like I said, with the 3D, you can create 3D environments, which opens up the possibility for virtual reality. You can perform particle simulations and physics simulations. And also even advertisements are made with Canvas. So some resources going forward, if you want to check out some more things, I provided a link to my GitHub where you can check out the code for this lightning talk. And I've also included some links to cool demos that I've found really inspiring using Canvas, some tutorials, and some third-party libraries. And if you do, I invite you to go in and fork the code and play around. And if you have any questions, please feel free to reach out to me and let me know how it goes. And with that, thank you for attending my lightning talk.